We want to focus on the softwares that are relevant to our hands-on training tomorrow. For those of us that are available on site, maybe in the lab over there at FUTA, a copy of these softwares has been made available so that you can easily collect it, put it on your laptop, and then we start the installation process. While for those of us that are online, I will try to copy the link also and maybe paste it in the chat box so that you can follow the link and get access to the download. But before we go into that, I would like to introduce us to the basis of computer. Because if you don't understand computer and how computer works, then we may not be able to do well on this particular course or in the aspect of bioinformatics training. The one thing that you must know about your computer is you must know the specification of your computer. Today they say I carry computer, but the requirements or the things that are present in that computer, they are almost useless. So by the time the computing system that you need to carry out bioinformatics, you must understand the specificity. So let's say now you have your computer over there with you. If I ask you what is the RAM size of your computer, you should be able to tell me without thinking twice. Okay. If I ask you, okay, what is the byte size of your computer, you should be able to tell me without thinking twice. If I ask you what is the operating system that you have on your computer, you should be able to tell me without thinking twice. So before I proceed or show my screen, I will like us even to do this particular pool so that we understand how familiar we are with all the software that we want to talk about this afternoon. Let me quickly get the link for the pool and paste it under the chat box. Okay, I'm coming. Okay. All right, so let me go to the chat box now. All right. So kindly access this particular pool so that we get your feedback about how familiar you are with all these softwares that we want to talk about this afternoon. And let me share my screen before I continue with other share document, share white paper, okay, share screen. Hello, can you see my screen over there? No, it's not showing. Display over Zoom, okay. Okay, while we are filling the pool, I want to share my screen. I'm still trying to get out through. Okay, all right. Okay. All right. So that pool, just to introduce us to various software that I want to talk about even this afternoon and how familiar we are with it. I will check over it after maybe about 5 minutes now. But let's start with basis of computer. When you have your computer over there, I want somebody to respond to me now. Can you tell me the operating system that you have on your computer and the RAM size? Anyone can answer?
My own is Windows, 16 gigabyte RAM.
Okay. What about the bytes?
Byte.
BIT, yes.
My own is 64. 64.
Okay. Yeah. So all those information, they are very, very essential for us to know, okay, this particular computer is suitable even for bioinformatics analysis. For those of us that are participating, we have to know the kind of specification we have for our computer, and to know that it's very easy. Just go to the search box at the left-hand side of at the bottom of your computer. Just type there about this PC, and you click on it. So once you click on it, it will bring out the information about your computer for you. So you bring out, okay, the model, if it's Lenovo, whatever, HP. Then it will show you, okay, the RAM size. That is random access memory. Okay, on this particular computer, you have 4 gig. On this particular computer, you have 8 gig RAM. On this particular computer, you have 16 gig RAM. And also we have what you call a kind of graphical or card. So if your computer is one that is supported with a graphical card, maybe they call it a GPU, okay? Then it will show you the amount of the RAM that came with that graphical card. So in some advanced bioinformatics analysis, it is preferable that your computer will be the one that have all these graphical cards, because by the time you are doing some kind of analysis, just like Dr. Salio said, you have to work with a lot of big data, which sometimes can cause your normal computer system even to be hanging. And when you have all these graphical cards, they hasten up the access to the original RAM, and also how your data is being analyzed. It will make it very easy for you. So for you to know about your PC, just type about your PC under that particular search box, click on it, then get information about your computer. Is it 32 bytes computer? Is it 64 byte computer? The level of RAM, then the level, the size of the hard disk. So we have two types of hard disk. We have the hard disk and we have the solid state. Okay, hard disk is term HD. So you can say 500 HD. That is the size that you can store all your data, your analysis on your computer. But there are some computers that came with solid state. This particular one, it makes access to your RAM very easy than hard one. Okay, it's a kind of a chip that is being installed, that has been installed with your computer. Okay, so it makes access to your RAM very easy and very fast than the hard disk. So if you want to buy a computer for bioinformatics, maybe later on, it's better that you prefer the one that has a solid state. Though some combine the two together. They have a part for hard disk, another part for solid state disk. So then the essence of what you have, the byte 32 or 64. 32 byte computer, they are the one of old processors, Windows 7, Windows XP, and some Pentium like that. So the significance of that byte 32 is that the maximum RAM they can work with is a 4 gig RAM. So they cannot optimize their computer, they cannot upgrade that particular computer beyond 4 gig RAM. But any computer that has 64 bytes can work with higher gig RAM, the one of 16 gig, 32 gig, 64 gig. I think we have, is it 128 gig now? Okay, so they can work with higher RAM. Okay, so make your work to be very fast. And not only that, there are some softwares that are compatible with all these bytes. Okay, as we will see by the time we want to install some of these softwares, there are some software that, okay, they are 32 bytes, and there are some that can only work with 64 bytes. Okay, if you have a computer that has a 64 byte processor, you can install either software that is 32 bytes or 64 bytes on it. It will accept it. But if you have a computer that is a 32 byte processor, you cannot install any software that is of 64-byte for 64-byte processor on it. It will not accept it. So it's the best thing by the time you want to get your computer, get the one that has 64 bytes. Then by that, you can have higher access to higher RAM, then have access to solid state disk. So all this one will help by the time you are doing your analysis and installation of your software. Another thing that I will talk about computer before I go to all this software is about your operating system. Okay, basically we have 3 major operating systems in the market today. We have the Windows operating system. Also, we have a Linux operating system, and also we have Mac operating system. I think these days Chrome operating system is being developed by Google, and it's not yet well known. So your operating system is very, very important. Operating system is the basis, is the foundation for your computer, upon which any other software, the browser, will stand. Without operating system, all those softwares, all those browser will not stand. Okay, so the operating system that we have in this part of the world that we have access to, just like other facilitators have said, is the one of Windows, being developed by Microsoft, Windows operating system. But in bioinformatics analysis, there are some softwares that cannot work, are not compatible with Windows operating system. That is where Linux comes in. So Linux operating system is very somehow lighter than a Windows in terms of installation, in terms of size and how it analyzes data. So it's somehow lighter than Windows and Mac. So the third one is Mac, which is basically developed by Apple. So they have Apple laptop and all the other devices. So that one also is being utilized. I think is the second after Windows. So Linux even still come third. But Linux in terms of bioinformatics is the first. Whether you want to do sequencing, whether you want to run simulation, is the first. Then after that, we have our Windows operating system. Okay. So that is very, very important. So by the time you want to download any software, your understanding of the nature of your computer will determine, okay, which kind of software do I want to download? Is it for Windows or is it for Linux operating system or for Mac? Is it 64-byte processor that I want to download it or not, 32-byte processor? So this understanding will help us to know how to download even our software. So, and the scale of installation is very, very important. If you can't install software by yourself, then you cannot go far in bioinformatics, because not every time people will be there to install software for you. So you must learn how to follow instructions, because most of these softwares, they have their documentation, which once you read documentation, you know, okay, this and this are the things that I have to type. These are the things I have to do in order for this particular software to be installed on my computer. So this understanding will help us by the time we want to download any software for our analysis. And all the software that we will talk about in the next maybe 20 minutes are the things that we are going to use in our hands-on training tomorrow. Hands-on trainings tomorrow. Yeah. Let me start with this. We have different programming languages. Okay. Different programming languages. We have Python, we have Java, we have Perl, we have C++, and we have a host of others like that. So the essence of this programming language, they are the algorithm that is being used to develop all these softwares. So one of these softwares or two of these will either belongs to one particular programming language. Okay, so programming language is a kind of language that is being used to develop the software algorithm. So if you take this particular software works with Linux, the next thing that you should ask that, okay, on which particular programming language does it work with? Is it Python? Is it Java? Is it Perl? Is it C++? Okay, but Python is one of the versatile programming language because it is known for its simplicity and readability, and it is widely applicable. They use it in different dimension. And these days, R also is coming up as a programming language because many software now are now being integrated using the R language. R language. So if you have R on your laptop, then there are some softwares that you can install into the R library, and from there you can have access to your analysis. So those of us that are online, you can see the link. I want to start with Python. I want to start with Python. So this particular Python, as I have said, is a programming language that has been developed since 1991. It's being used for web development, data analysis in data science. Data science, you have different kind of library in it. We have NumPy, Pandas, SI, and it's being used for visualization, scientific computing, anything related to data analysis. You have it in the Python library. Then we have machine learning and artificial intelligence. These days you are about AI, artificial intelligence. So it's about, okay, which programming language does this particular artificial intelligence algorithm is based upon? Then another thing, maybe you want to develop a game. So Python is one of the compatible programming language that we can use to develop game development, app development, and the rest like that. Okay, and it has a versatile what's it called? A versatile application, versatile application, so that most of the software that we'll be talking about, the Python, the PyMol, Autodoc Vina, all those things, they built upon Python. While some applications like EdgeR and the rest like that, they built on our platform. While there are some software that are built upon Java. That's why we want to install these things at this particular point of the training. So for those of us online, I will click on the link to Python now. It should show on my screen. Okay. So this is a website. Once I click on Python, this is a website. So the latest version of Python is Python 3.1, 3.11.3. Okay. If you tell you, okay, you are looking for Python, you will ask you, we have different operating systems. So which operating system do you want to install this Python for? So if you are using Windows operating system, you click on Windows. If you are using like Linux operating system, you click on Linux. If you are using Mac, you click on Mac. And if you are using other operating system, just as I've said, there you click on that to see other versions for that your operating system. So immediately you click on this particular, maybe you are using the one from Windows, then just click on Windows now. It will start downloading. It take you to where it will download. Then from there, you can now click on it. Latest Python 3.1. Just click. Once you click on it, it starts. The downloading will start. So immediately the thing downloaded onto your computer, you see it under download. So once you click on it, just click run. Just like we run other application. Once you click run, then it will install. At the end of the installation, it will tell you finish. Okay. So when it tells you finish, where you can find that, it will be under your program 86 or program other program on inside your local disk. So it's as simple as that. Before just join to what is to download. But for those of us that are available on site, you can collect the copy of this downloaded version from our host and install it on your computer. Very straightforward. So there is no big deal even about this. Let me go back to my slide. Okay, the next programming language is Java. So there are some softwares that are built upon Java. Okay, Java is the basis for their development. So they run based on Java programming language. It started in 1990s also, and it has a versatile application in terms of game development and software development. But nowadays, it's being used even for development of bioinformatics tools, bioinformatics software. For example, like this. What is the name now? There is this particular software that I often use recently. So if you don't have this particular Java installed on your computer, by the time you download that particular software, and you want to run it, will not run because it doesn't have a basis for it to install on your computer. So that is why we want to install this essential programming language on our computer so that any other software that you want to download or install, either Java, either Python, then you can easily install it on your computer. So it has various applications also, just as I've said. That various application is being utilized maybe in development of business enterprise application, maybe those that do reservation online and the rest like that. The hydro development, in hydro development, mobile phones is being utilized a lot. But these days, there are some softwares that are related to bioinformatics that are based on JavaScript, So to download this particular one is also very easy. You have 3 ways. Okay, let me click on the link. So that is the link. Okay. Okay, the network, okay, it will show now. Okay. So that particular name will take you to this particular site. Okay, tell you about Java license, but just scroll down. Okay. Here we have for window. It will tell you how do you want to download the Java runtime environment. How we represent runtime environment. How do you want to download for your window operating system? If you click this first one, window online, it will download a small size, what is it called, execution file for you, 2.2 MB. But immediately you click on that 2.2 MB to install it, it will take you back to online. That means it will require internet access for your installation to be completed. Okay, so if you click that particular first one, it will take you back to online. By the time you want to install, you must have internet access for you to install the full Java runtime environment on your computer. But if you click the one of window offline, it will download the 56.89 MB onto your computer. But this particular one, I think, is for 32 bytes processor. Okay, so if your processor is 32 bytes, then you have to download the one that is window offline. Okay, window offline. But if you are using 64 bytes processor, then you have to download window offline 64 bytes, which is 62.62 MB. Okay, immediately you download it on your computer, it will be under your download. What you just need to do is to click on it and then click run. So by the time you click run, it will install the whole package of Java runtime environment onto your system. It could take a while, maybe like 5-10 minutes or more than that. Okay, so that is about that. So if you are using other operating system, you just need to scroll down to the right operating system that you are using, either Mac operating system or Linux operating system, and this. And in Linux, there is a way that you can install some softwares without coming to download the software online separately. So Linux have that opportunity. Okay, so if you are working with Linux, there's a way, okay, sudo gets particular name of that app, automatically it will download the thing for you. So, but that kind of opportunity, we don't have it in a Windows operating system. So Linux is, the working of Linux is somehow similar to Windows. If you can operate very well, if you can operate Windows operating system very well, there just needs maybe a little change in some command for you to work on Linux operating system. And there's possibility to have on your computer both Linux operating system and the Windows operating system. What you just need to do is to partition it. Okay, but there are some sophisticated systems these days now, like the one that Dr. Saliu used. I can see Legion. That is one of the latest laptop you can have access to as a bioinformatician, because it has a lot of all these graphical card, NVIDIA, then all these essential things that will make the graphic come up. Then you can easily partition or install more than one software operating system on it. But for the one that you have that is having maybe iCore 1, iCore 3, iCore 5, iCore 7, you can still install Linux operating system together with your Windows operating system. What you just need to do is to partition it. By the time you want to use Linux, you have to switch over your operating system to Linux. By the time you want to use a Windows operating system, you switch back to Windows operating system. So that is about JavaScript. So immediately you install it, it will be there for you. But that is not the real software. This is just a programming language that serves as a foundation upon which other softwares that are related or that are built using Java programming language we stand upon. So that is the link. I hope you can see it. www.java.com/en/download/manual.gsp. I will still paste all this link into the chat box. Maybe I should even quickly do that so that some of you can follow me as I am doing it. Let me quickly do that. Sorry. Okay. So I want to paste the link into the chat box so that as I'm speaking, if you want to click on it, those that are online, you want to download, you can easily download. Okay, those are the link. So you can easily click on it and then follow as I am introducing you to the installation. All right. The next thing that we need to install is okay, how? Okay. Dr. Salu made mention of this during his analysis that for us to analyze all those genomic data, maybe the one we obtain from snRNA, or the one that we obtain maybe by using of other high throughput sequencing. Okay, so we need R. So R is a kind of programming language these days, and it's an open source software. Okay, basically it was developed maybe for statistical computing, but nowadays they are being incorporated to biological aspects. And the essence of R is that it gives you a good data analysis. The graphical techniques is top notch, and is very compatible to other packages. So if you want to install R on your computer, it's very easy. You can install it based on maybe the location that you are across the world. But for this particular link, it's basically meant for global audience. So if I click on this, you see different operating system that you can download our R. So, okay, this is where that link will take you to. Download and install R. Okay, if you are using Linux, say download R for Linux. We have different versions of Linux: Debian, Fedora, Ubuntu, depending on the one that you have. But the general name for all these things is Linux. Then if you want to download the one for Mac operating system, you click that. If you want to download the one for Windows, you click on it and you download this. It will download under your download folder on your computer, maybe about 86 MB or 80 MB. Okay, so that's what you should expect. Okay, so that is about that. So immediately you download it on your computer. Once the download finished, just go under your download file, then double click on it. Then it will tell you, okay, you just follow the instruction on the screen. Okay, next. Okay, which particular folder is only you that want to use it? Okay, next. Do I need to make a kind of a shortcut somewhere? Yeah, you click next. So you just finish the install. It's very easy, very straightforward. So just follow, okay, next, do this on the screen. I'll not be able to do that now because I'm not working from my computer. But once you download, that is the most important thing. Once you download it, the right version for your system, then just normally the way you install every other software, just double click on it and then run. So once you start, the installation will start. It could take some time also. It could take some time, it may not be immediately. You have to unwind all the other packages that are available in it. So that is about R. And it has wider application, just as I have said, especially in the area of functional genomics, data science, and all the sequencing analysis and the rest like that. Even there was when you are doing GWAS, genome-wise analysis associated study, you also need to use R to analyze your final data from the GWAS when you are working with Plink. Plink is that particular software. Okay, I don't want to go into that now. So R is a very good software or programming language that we have to learn and know. And you don't need to know all these things once and for all. Just like we are considering SNRNA, even in this particular course now. So once you can grasp the script and how to analyze SNRNA. So some of these, what is it called now? The scripts, they are peculiar to the kind of a software that generates it. Okay. So once you know, okay, which data are you analyzing and you know the script, you don't master that particular one. By the time you are working with another set of analysis that requires R, you master this. So it's not until you master everything from the beginning to the end before you can use all this software. Just like what is it called? Dr. Salu said, he started learning the use of R just more than a year ago. Also, I also have an encounter with it, I think maybe 2021 or 2022 also. And little by little, the aspects that are peculiar to my analysis, once I can understand that, then I can reproduce it, work on it again, apply it to another study, and by that, you develop the expertise. So that is just about R. It's not difficult. But if you look at this particular point here, it says integration and interoperability. So R can be easily integrated with other programming language. That's why it's very robust. Other programming language like Python, Java, C++. So those are the existing well-known programming language. So R could be integrated into all these Python, and it can also be used to connect with database, spreadsheets. As Dr. Salu said the other time, sorry that I'm referring to it often and often. When you unwind or unfold your matrix data sets, okay, there is possibility that you can visualize that data set, especially the one that has TSV, you can visualize with Excel. Okay, so once you visualize with Excel, then R can help you also to import that particular Excel into where you will finish the analysis. So that is one of the essence of R. That's one of the essence of R. Then in machine learning and in academic environment, in statistics, that are in mathematics, so they make use of R also. So in bioinformatics, R is a very good tool that we have to master and understand how to know. Then another one that I will talk about is R Studio. R Studio. R Studio is not R itself. It's just a kind of a tool that will help you to understand the script or what is being done by the scripts of R. R is the real software, while R Studio is just like a studio. Studio is not the real musician. So R is the real musician, while Studio is just where you can mix things together to get your results. So R Studio is an integrated development environment specifically designed for R programming language. It provides user-friendly interface and comprehensive set of tools to support R data analysis and the workflow. So we have both open source and we have the commercial edition. But in this training, we are going to use the one of open source, which is about 208 MB. 208 MB. So if I click on this, let me click on this particular link. It will take us to where we need to download our R Studio. So it gets you to the right place where you will download the R Studio. Okay. So you need to install R first before you can use R Studio, because that is what it will work with. So you have to first install your R. Then choose the right operating system. Then you can now install R Studio. R Studio. So we have different operating system and different bytes operating system that you can download. And over here we have for Windows 10 and Windows 11, you can download this particular one. It's about 208 MB. Then for Mac, you have to download the one that are relevant to Mac. Then for Ubuntu, which is example of Linux, you have to download the one related even to that particular version of Linux. Okay, so Fedora, the example of Linux, and all the rest like that, the example of Linux. So that is about that. And all this software, every page that you go to, they always have documentation. So if you want to read more about each of these softwares, just go to part of the page and read about their documentation. Let me see here now. Okay, learning and support. Let me scroll up if it will allow me. Okay, let me see under learning and support. So if you click under learning and support for, okay, you can see resources, blog, videos, and the rest like that. So any software that you want to learn more about, just visit the site of that particular software, go to under documentation or resources. Then you see an example that you can easily lay your hands upon on how to use that, that particular. You can see documentation here. So by the time you click on documentation, you can easily read more about how to use this particular software, installation, how to upgrade, user guide, and all the rest like that. You see it under that particular place. So let me go back to here. So also the installation of this one is also straightforward. Just install it like normal software. Is by the time now that you want to link it to R, which our facilitator will inform us better tomorrow, how you want to link it with R, that things that you need to do in order to link it with R, so that as we are writing some things on R Studio, it will be making effect on R, and you get the result back under your R Studio. So that is about R. Dr. Salio will still say one or two things about R by the time I finish. So I will quickly fast about this. Then another software that is very useful in bioinformatics. Maybe you are want to view biological structure, you want to view compound structure, you want to edit. So is this particular PyMo. So it's a powerful molecular visualization software that is being used for analysis and rendering 3-dimensional molecular structure, whether protein, whether DNA, whether RNA, whether your compound, your chemical compounds. So whatever it is, PyMo can easily make you to visualize it. And by visualizing, you can see, okay, the cell arrangement of amino acid, okay, there is an enzyme, and you want to use it to visualize maybe the binding site. Once you can see the curvature and the cavity, by the time you set it to 3D visualization, you can see various cavities that are present in your protein or your enzyme. So it's a very wonderful tool which we are going to use tomorrow during our hands-on process. And the installation is very straightforward. What you need to do is download this particular software, the one that is very compatible with your operating system, download it. So once you download it and you install, that is all. Okay. So we have the one that are commercially available, then we have the one that are for education. But the one that I want to download is the one that it will require activation, but we don't need the activation. The basic feature that we need is enough for us. So we don't need to activate it. So if you click on this particular link, pymo.org/2, you tell you, okay, you want to download different version. Okay, what is the version? It's being produced by Schrodinger too. Schrodinger has many bioinformatics tools, softwares, such as Maestro, Desmond, and so many others, especially in computational chemistry. They have other tools too. But the one that we want to download is PyMo. So the latest version is PyMo 2.5. So what you're going to do is to click download now. But you have to check under the download now. The type is the one that's compatible to your operating system. Let me click on download now. Okay. You can see underneath. Okay, it says download 2.5, but now says window execution installer. So this particular, you click on the window execution installer, it will download small size for you. By the time you want to run it, you still need to connect back to the internet. If you download the one of exe installer, it will still connect you back to the internet. But if you download the one that is not execution installer, then if you download this one, it is the full version of the software that you want to download, and it's very big, maybe about 400 MB or so. So you have to know that you have enough data. That's why I told our host, Professor Akimaladun, to download those ones so that people that are on site will not need to download again. So you can easily copy it and put it on your laptop and then install. So you download based on your operating system too. Based on operating system. So if you are using Windows, you download this full version. But if you download this one as an execution installer, you still need internet access for you to install the full software. Okay. So all this particular Python also is compatible with Python 3.7. Python 3.7. So by the time you are installing it, will tell you, do you want to use this Python 3.7 or you want to use the Python that you have already installed, which is Python 3.11, which is advanced version than this. So I prefer that you use the one that is advanced so that this particular one will not be the one being utilized in your analysis. So that's about PyMo. It's very straightforward. The interface is very good. So if you download this particular one, if you asking for activation key, just close the activation key, and then you can use any other basic tool that are there for the purpose of our training and even for academic training. That one is enough. But if you now maybe commercial purpose and business purpose, then you have to get the full version, which will require you to buy the activation key. So that is about PyMo, molecular visualization, structural analysis, surface, electrostatic, molecular docking. If you want to visualize the binding of the ligand and the receptor or your enzyme after docking, you can use PyMo also to visualize the docking pose. And also it will show each of the ligand where they bind to on the protein. So be able to visualize it. If you are the one that is looking for active site, you're able to know, okay, this particular ligand number so is the one binding to the active site, while this other one is binding to another site, Okay. Also, it can be linked to molecular dynamics simulation to visualize how the simulation is being done, trajectory and the rest like that, to visualize how the simulation is being carried out. And also it could be integrated with other tools in molecular biology too and computational chemistry. So it's a very good software that both if you are in structural biology, drug discovery, protein engineering, maybe you are mutating your protein and you want to see, okay, how will the structure look like? You can visualize the effect of that mutation, deleting one amino acid and the rest. You can easily see the impact by using PyMo to visualize. Another visualization which we are not going to use is VMD. You will see it in the pool. It's one of the questions in the pool. So VMD is also a visualization like PyMo. They often they do almost the same. They perform the same function. So another software. Hello, I want to get a feedback. Can you hear me, sir?
Yeah, we are following.
All right, sir. Okay, I will soon round up now. There we entertain questions so that we round up for today. Another important software is this ChemSketch. We will be talking about medicinal chemistry, how to generate new compound, how to optimize. All these things, they do it by applying human intelligence to the existing scaffold, just like our last representative, Dr. Josiah said. So once you understand the existing scaffold, then you have to redraw or attach other functional group. If it is the benzene you want to attach, you attach. If it is or is it called now, another functional group, COOH, want to attach to the existing scaffold, then you draw it, you construct it. So this particular software is where you can do it. We have other versions like ChemDraw and the rest like that, but this is the one of the most freely available ones that you can do all this one without any restriction. So once you have your structure, you can draw the structure using particular software. You can copy the, what is it called, the scaffold from PubChem. From PubChem, get the basic structure of your initial compound, you upload it into this particular software, then delete anyone that you want to delete. We call it optimization. Okay, you want to remove one functional group, attach another functional group. You want to delete one carbon chain and attach another carbon chain and save the structure back to perform your analysis. So this particular software will help you to do that. You can draw any structure based on any scaffold that you want to start with. Let's say, for example, you have idea, okay, quercetin, the structure of quercetin, okay, this is it. You now say, okay, I want to optimize this particular structure of quercetin that's normally present as phytochemical. I want to optimize it. Okay, so what you need to do, okay, get the structure of quercetin for PubChem or from any other database that has been mentioned, get the basic structure from, then upload it into this particular chem sketch. So on the interface, you see the structure of quercetin. Then any area that you want to optimize or you want to change, maybe you want to change the OH, hydroxy group, you want to change this to amide group, then you can easily draw it and then save the structure back, get the SMI, which is a small molecule iterative clinical language system, is there on the PubChem too. So that particular one, you can easily work with your chemical structure. Then you can also use it to design a kind of a chemical reaction for your organic synthesis. You don't need to use your Microsoft Word or your PowerPoint. So this one, all the elements, they are there, they are available inside it. Your chlorine, all the elements, the periodic table. So everything are there. So you don't need to click and add to your structure, construct your chemical reaction pathway and the rest like that. So it's very, very useful, and you can't miss it if you want to go into bioinformatics, especially in drug discovery. So there's point in time that you have to use it. And also, if you want to visualize maybe the spectral analysis, how the fingerprints of your chemical compound, you understand, for you to decipher or elucidate a chemical structure, especially the small molecule, you have to use NMR, which is a nuclear magnetic resonance, or you have to use infrared spectroscopy. Those are the things they use in organic chemistry. But in biomolecule, you can still use NMR to determine your protein structure. Then you use X-ray crystallography. Then you use your cryo-electron microscopy to determine the structure of your enzyme or your protein. But for chemical compound, you use NMR and the infrared spectroscopy. So they say, go and bring me that particular, what is it called now? They call it in the chemistry language, call it is it profile or chromatogram or whatever. So spectra, okay, they call it spectra. So and they will start interpreting. So these particular tools you can use to predict how the actual spectra of your compound will look like. So by the time now you now use your infrared spectroscopy or NMR to get the spectra, you can now compare. So you have insight into what you are expecting in the real life. So that is the thing that you can do with this chem sketch. To download is a very important tool in pharmaceutical company, and also for us that are doing research, academic research. So all the optimization, scaffolding, increase, linking, and the rest like that. So you can link two or more scaffolds together using this particular interface, then save it in 3D form, then go and conduct any other analysis that you want to conduct with that particular compound. So to download is very easy, it's very straightforward. Just go to this particular link, just click on it. Well, by the time you click on it, it take you directly to where you will download this chem sketch. It's free for academic purpose and personal use, not for business. So once you download, the size is not that much, maybe around I don't know exactly, maybe around 120 MB or 200 MB. Okay, so you have to download. So once you download, to install is very straightforward. the way you have been installing the other ones. Just once the software has been downloaded into your under your download folder, just double click on it and run. Then follow the instruction that show, okay, I agree, I accept, and then continue clicking I agree, next, and the installation will finish. So immediately it's finished, you can open it, then see how the interface looks like. Just play around with it as if you want to, you are drawing something that is unknown before. You attach benzene with the cyclopentane, attach with the chlorine, add the bromine to it, and then save it and see how it will look like. So those are the usefulness of a chem sketch for you to draw, generate a smile. You can also use it to generate IUPAC name for your compound. Maybe you design a new compound that has not been existent before. You can use this particular software to generate the IUPAC name, to generate the SMILE annotation, which you can use for your admin pharmacokinetics study and the rest like that. So it's a very good software that you can lay your hands upon. So let me quickly move to the, second to the last, MGL2. So MGL2 is also called Autodoc tools. So it's a tool that has a graphical user interface and is being used to prepare file for molecular docking, especially molecular docking that involves the use of Autodoc or Autodoc Vina. Okay, we have a software that I call Autodoc. Okay, it's being used also for molecular docking, but this day Autodoc Vina, that was developed by Scripps Institute in the United States of America, is a versatile version of Autodoc that academic people laid their hands upon, and it generates a lot of beautiful results, even than Maestro. One of my colleagues told me that when he docked using Maestro, he obtained lower binding affinity. But by the time he compared with Autodoc Vina gave him more good results. So Autodoc 2 is a kind of a software that have a graphical user interface for you to prepare. You can use to analyze or visualize your molecular docking. Okay, so we use it tomorrow by God's grace. So we use it to prepare our file, our ligand, and our protein. We use it to prepare it for docking. Then we set up the parameters configuration upon which the docking software we make use of. We generate the grid box, then the docking configuration. Then you can use it to visualize the results. Okay, ligand protein binding result interaction. You can use it. You can use it also to visualize that. Then also we can use it to what is it called now? Okay, and so that is basically the tool to prepare our file for docking. If you understand how to use that particular tool very well, you can link it for virtual screening. Okay, virtual screening where you will connect your Autodoc Vina at one end, then you connect to an additional library, just like our lab presenter said, additional library, maybe connect to PubChem or to drug bank. So Autodoc 2, we try to match between the database and the Autodoc Vina and try to do the docking, and you can see. But we are not going to do that tomorrow. We use the online server to explain virtual screening briefly. Okay, not every time you'll be doing virtual screening, you have your potential compound available, then there's no need for you to do virtual screening. Okay, but if you have a new molecular macromolecule protein or enzyme that you want to know which existing compound can bind to that particular protein or receptor, then you can do virtual screening. It will screen thousands of compounds that are available in the chemical database, then give you the top best, maybe about 10 that can bind to that particular protein. Then from there, you can start any other analysis you want to do, maybe to optimize the structure or to design another one, then you can go ahead from there. So if you click this particular site, it will take you to the download page for MGL2, which is also known as Autodoc 2. It will take you to the page. Okay, this is MGL2. Okay, so we have this version, which supersedes the previous one. So that's what we have there. Okay, this is how the interface looks like, thank God. This is how the interface look like. Okay. So on this particular place, by the time you want to set up your, what is it called now, your docking dimension, if you want to focus on the active site, you can easily generate the box by knowing the amino acid that belongs to the active site. If your target is just to focus on the active site, then you can easily target the active site. But if, sorry about that. But if your, okay, but if you want to focus on, okay, you are not just interested in the active site alone, you are still interested in the allosteric site. Okay, allosteric site, that is site for regulation of that particular receptor or that particular enzyme. Then you have to do what we call blind docking. So the box has to be placed on the whole structure of that particular enzyme. You capture the whole structure so that by the time you are running the docking, the ligand can easily bind either to active sites or to other sites, So regulatory site on a protein could be more than one location. Okay, it could be more than one location. So it's very, very important. So you can easily determine that by the time we are doing our setup, locating which amino acid, if it's active site, we want to target, or if you just what we call blind docking, just want to target both the active site and the regulatory site. You can easily set it up before we proceed to VINA. So to download, you can easily download from here. Just go to download page. So by the time you click on download, it will tell you, okay, this particular version, okay, download. What's happening to this particular link? Projects, gallery opportunity. Let me go back home. I think you should have it under the download there. Okay, I think this particular one not show us the exact download link. Before we finish this particular, I will try to look for the exact link to download this particular one. MGL2. Okay, this particular, okay, visualize C++, download the binary here, download. Supposed to go. But if this one does not show the exact download, then I will try and get the link and then forward it back to us before we start tomorrow. So let's proceed to the last one, which is Autodoc VINA. Autodoc VINA is the main software that's really doing the docking. In our case, we are using Autodoc software, Autodoc VINA software. There are other softwares that are available for docking outside there. We have Glide, we have Yasara, we have MOE, we have Maestro, which is from Estrodinga, and we have a lot of others. But the one that's we often recommended or use in academic environments, even there are some industry that implements Autodoc VINA in their pipeline, because the thing is very robust, and it gives accurate scoring. So VINA have efficient docking algorithm. Okay, that is, it does the binding efficiently. It searches both the ligand and the protein to ensure that they have energetically favorable binding. In enzymology, in thermodynamics, the lower the binding energy, the more the negativity delta G, then the better the whole process. So the same thing here. If in docking, we go with the one that has the lower energy. See, delta G has to be more negative. The more negative the delta G, then the better the affinity. So that is just the principle that Autodoc VINA also based upon. Then Autodoc VINA make use of the file that we have prepared in PDBQT by using our Autodoc tool. Also, There's a possibility of doing flexible receptor binding sites. That's another thing that you can dock. Then the scoring function of Autodovina is very good. It predicts good binding affinity, and also visualization analysis can also be done by the result that we obtain from Autodovina. We can visualize it by using Autodoc 2, by using PyMo, and by using other online visualization tool or web server. So we did more about that tomorrow. So these are the tools that we lay our hands upon tomorrow, and they cut across if you are working in drug discovery, if you are working in structural biology, if you are working in what have you. So one or more of these tools, you will make use of them in your analysis. So tomorrow we will use almost all these 8 softwares. So ensure that you download each of these software into your computer and install it. The installation is straightforward. So so I will give room for our question now. And even before that, Dr. Sali wants to say 1 or 2 things about R. So I will give him a chance to say that before I entertain question. Okay, Dr. Sali, you can come up.
Dr. Sali, please unmute and.
Okay, yeah, sorry. I was stuck here. So, yeah, this is just a way of saying some things about our, like, I don't want to go back to what Dr. Patoke has said. So install R and R Studio. Majorly we'll be using R Studio, but R Studio cannot work without R because what R Studio is based on is on R program. So R Studio is still like a sophisticated one. It's still more user friendly. That is, you can follow whatever you are doing. You can follow whatever you are doing. Here is the code, the place you write your code, and here is how you follow whatever the result of whatever you are running here, which is the console. Then here is the result. You see a result of the code that you have run. So before like all this programming, they are like a way in which you tell your computer to interact with the computer to do a certain task. So for R to for you to interact with R to do a certain task in analyzing your single cell RNA-seq or single nucleus RNA-seq, you have to install some packages on the R. So these packages will tell the R, okay, I want to do this particular task, do it. So without these packages, R will not work. Like the code you are writing will not work. For instance, I'm coming. I want to work on this Sierra object. Let me close it and open it. No, don't want to close it and open it again. Yeah. So I'm coming. Should come up now. Yeah, so this is a new page entirely. Yeah, the title of what you want to do, let's say footer, whatever you write it, my name, if it is your name, you put it there. Then the time is automatic, the date is automatic, they have set it to be automatic. Then the default output of your results is either you want to be in HTML, PDF, or in Word, you include it. So this is the title, the author, whatever, and all that. So for you to, first thing, I don't want to do this tomorrow because whatever that we are doing tomorrow is going to take a lot of time. So I don't want to use that time to be explaining all this tomorrow. So first thing that you want to do is you set up your working directory so that whatever the output that you are getting will be going into that particular folder on your laptop. So what you just do, the code you just write is set set working directory. Then set working directory. Then you put in the code. Then you put the path, the file path of the folder in which you want it to be. You put it there. Let's say I want it to be in download, like I've done for this. Let's say I want it to be, for instance, here. I want it to be here. So what I will just do is I'll just copy the path, the file path, then paste it here. Then change it. R does not recognize this backward slash. You put it to forward slash. Every backward slash will be forward slash. Then without this code, it will not work. Then you run it. You can run from here. Once you run it, you have set it. See, this is it. You have set it. So let's say I want to use the Sarah. Let me. Yeah. So I'm coming. So yeah. No. Sorry. Yeah, so I want to tell the computer to do a certain thing on this R. Say I want to analyze, let's say, this particular, it's called large CRAT. So, and I say, okay, let me say footer, then assign it something. Let me say I'm using okay, now let me run this one code. So whenever I'm doing any work on this particular objects, because I did not load the correct package, I did not load the package, which is CRAT. Any work I'm doing is not going to work on it. So I have to load the relevant package that will be used for a particular, for analysis of a particular object or analysis of a particular work that you want to do. So the first thing is you load in the packages. Now, first, these are the packages. For instance, here now, I want to work on CRAT. You load the package CRAT. You load the SCT transform CRAT. You load the calc or ggplot to plot your whatever plot you want to plot. This one for color digital plot is also used for plotting. Then Lima is used for another thing. So for you to do some of the analysis, you have to first install these packages. This package doesn't just come like that. You don't just open R and start working. You have to load in this package. How do you load the package? This is how you load the package. Like library, then you put in the package you want to work with. But before you load in the package, you have to also install these packages. So there are 3 repositories that you can use that hosts packages on R. Sorry. Yeah, you have the CRAN, which is the official software repository of R. Then you have the GitHub. Then you have the bioconductor. These are the 3 repository of R where you can get packages that you can work with on the R. For instance, yeah, for you, this is, you go here, this is the packages, then you say install. These are, before I say install, these are the packages that has been installed on this particular R studio. So whenever I want to use it, I will just go here and I say library. I'll put in library and put in whatever package I want to use, or probably I'll just click this, it will put it there, or click any one of the package I want to use, put it there, and it starts, it will just put it there. So, but if the package is not there, you have to go to this place, then from the repository, which is the CRAN, then you put in whatever package you want to use. If it is CRAT, it will bring it. You have CRAT object, one you want to install, then you put it, then you click install. So it will install, but he said, do you want to install R to install that? Do you want to restart? No, I don't want to restart. So it's playing, would you like to install this Miniconda? This is the package. This is the command that you're supposed to use to install it. So once you do this, it will do the same thing. Then you put, please answer yes or no. If it is yes, you can say why. Sorry. So it will load. It's loading. Do you like to this? Say why again. So that means once you see this, that means it has installed. Then for you to use it, you just come here and you say library, then Sierra. Once you put it, then that means you can start working using this Sierra. You can start working on Sierra. You can start working on different packages for you to do your work efficiently. These are the packages I have installed in this script. Then also for this script, these are the packages I install. If I have your Venn diagram, you have to install the Venn diagram. Then after installing the package, then you have to tell the computer to, if you want to use the Venn diagram, you have to load the library, that is the package for you. And then after, yeah, so that is CRAN. For GitHub, GitHub is not the repository of R, but you can use package that has been developed by other people on R. So if the package is built with R algorithm, then you can download those packages from GitHub and also from Bioconductor. These are just open source software for bioinformatics. So for you to install any software from GitHub, you have to communicate from CRAN, which is CRAN rather, from CRAN, which is the official repository of R. You have to communicate with GitHub. So how do you communicate with it? First is you first load this package, which is called remote. What I like I have done. So once you install the remote, once you install the remote, then you use remote to communicate with CRAN on R to install the package. Just a remote double column 2 times install _ GitHub, then the particular package that you want to install. So once you install the particular package, then you can load in it and start using it from library. Then for Bioconductor, you have to install BioC Manager first on this CRAN package, like I've done the other time, using install.packages. Then you put in BioC Manager. So once you put it there and you install BioC Manager, then you communicate with Bioconductor using BioC Manager. So you have the BioC Manager, double column 2 times, install, then the package that you want to install. So once you do that, once you want to install package from Bioconductor, this is what you use. Once you want to install package from GitHub, that's what you do. So not all the, not all the packages that are available, not all the package that you use in analyzing your data is on CRAN. So someone might have developed a software that is used for a particular analysis of a particular thing that you want. Sure you get, so you just have to go there and install it. For instance, let's go to the Bioconductor. This is Bioconductor package. Bioconductor software. These are the packages. You have a lot of packages that have been developed on Bioconductor. So whatever package you want to use, you just go there. For instance, let me pick one here. Let's say you want to annotate annotation to our annotation hub. You want to annotate your whatever that you have done. Once you click it, it will tell you before you can install this, you have to do this is it. Once you have installed BioC Manager, this is what you do. Let me copy this, then paste it here. So you can see it's running, it's installing. I'll say no because I don't want to do that. So that is, it has completed the installation. So if you want to use it, you just write library, then the annotation to so you can start using it. So that is how to install packages on R so that you can effectively do whatever analysis you want to do on your for your data that you have. So I don't want to do this tomorrow. That's why I'm doing it now. Yeah. Thank you.
Thank you, sir, for that presentation. We should know that if you want to install anything on R, you have to connect to the internet. Okay, you have to connect to the internet before the installation will work. So that is very, very important. All right, if you have any question before we round up.